Hey guys, welcome to lesson 2 of week 3, where our goal today is to solve exponential equations. Now, exponential isn't anything scary. You've actually been working with exponential expressions this whole time. Starting with a warm-up, I want you to evaluate this fractional index, and I would like you to write this guy over here as a surd. So take a moment now, write those down. I want you to upload those to OneNote by the end of the week, please. Moving into exponential equations. Now, exponential equations very specifically have the variable in the exponent. Now, exponent is simply another word for index. Okay, so you've been working with indices for the last few lessons now, so nothing to be afraid of at all. So if, for example, we have a look down here, x squared, that just looks like a normal index expression, equals 4. Well, now that's an equation because it has an equal sign. This is an exponential equation. And it would be our job to work out x because the variable is in the exponent. Okay? This isn't to be confused with x squared. X squared is not exponential. Just because it's got an index, that's not where the variable is. Okay? So, in order to solve exponential equations, you must work with both sides of the equation, so the left-hand side and the right-hand side, until they have the same base. So remember, when we work with our index laws, unless they have the same base, there's really not a lot we can do. So we're going to do a couple of examples today. I'm going to show you how to work both sides of the equation to evaluate exponential equations. Here they are. Let's get excited. So, first of all, having a look here at 2 to the power of x is equal to 16. Now, at the moment, there's not a lot we can do. It is our job to work the right-hand side of the equation to get the same base as the left-hand side of the equation. So let's do it. 2 to the power of x. Now, can I think of a way to express 16 with a base of 2? And the answer is yes. 2 to the power of 4. Okay? Now, here's the cool thing. If 2 to the power of x equals 2 to the power of 4, that means that has to be 4, right? That's it. Therefore, x equals 4. That's the only way that equation can hold true. Now, this is an easy example because we can easily just pop these in with the same base. Let's have a look at example B. 3 to the power of x equals 1 over 9. Now, this is a bit trickier. The first thing I'm going to recognize about the right-hand side of my equation is that 9 is 3 squared. So I'm going to write that in, 1 over 3 squared. But that's still not super helpful because it doesn't look like this yet. But hang on a moment, I can employ my negative index rule to write this whole 1 over 3 squared as 3 to the negative 2. Now we can see if that's 3 to the x equals 3 to the negative 2, that absolutely has to mean that x equals negative 2. All right, so this one here required a little bit more working. And with these as well, guys, it just takes time working both sides. And that's why I asked you last lesson to sort of, you really need to get used to what are your 3 to the power of probably up to 4, 2 to the power of up to 5. Know all your squares and cubes probably up to 10, okay? You can quiz each other on them. But then it gets a little bit more tricky. So we have a look at example C, 25 to the power of x equals 125. The problem is 25 squared, all right, is way bigger than 125. So already we have an issue. We can't just, immediately look at this and be like, I know the answer, like over here. Instead, what we need to think of is, okay, is there anything common about these guys when we're talking about indices? Now, I know this is 5 squared, and I know this is 5 cubed. So I'm going to work with that knowledge that I have, knowing that 25 is 5 squared and 125 is 5 cubed. So in other words, I can write this as 5 squared to the power of x equals 5 cubed. Now I'm going to employ an index law here. All right, remember when I have a bracket, I just multiply my indices here. So I end up with 5 to the power of 2x equals 5 to the power of 3. Okay, just going to have to give myself a little bit more space here. So what that means, guys, so if 5 to the power of 2x equals 5 to the power of 3, that means that that index has to equal that index. So 2x is in fact equal to 3. And a simple rearrangement will tell me that x is therefore equal to 3 on 2. And if you don't believe me, and if you always want to check in your exam, pop your answer into your calculator to double check. So this, as you can see, we're getting increasingly harder when we're evaluating these expressions, and we have to employ all these index laws along the way. Finally, we have something tricky like this now. Okay, we have 3 to the power of 2x minus 1. So we actually have an equation in our index, or in our exponent, equals 27 to the power of x. Well, the great news is that I can see, okay, well, I've got a base of 3 here, and unfortunately 3 is a prime number, so I can't really divide it by anything like I could with 25. But 27, I know that that's 3 cubed. So let's work with this for a moment. So I end up with 2x minus 1 equals 3 cubed. I'm going to expand that right-hand side now. All right, so 3 to the 2x minus 1 equals 3 to the 3x. Now, just like in example C, I now have the same base, but my indices aren't solely an x. But that's okay. They don't have to be. What we can make the statement of now is that this index equals that index. So 2x minus 1 is equal to 3x. And now we have a nice, beautiful linear equation that we can work with quite simply. So if I rearrange all of this together, all right, I'm going to end up with, let's take 2x from both sides. Okay, so negative 1 equals x. Therefore, x equals negative 1. That is my answer to question D. Now just remember, guys, we don't want to ever leave our answers like this. If we're solving for x, we want to write x as our subject in our final line. In blue over here, I've got some try these problems in increasing levels of difficulty. Take a pause now, have a go at those. All right, and when you're done, I want you to have a crack at exercise 3I, ACG of each questions 2, 3, 4, 6, and 9, okay? And then if you're looking for a challenge, question 12. I'm going to pop up the answers for the try these now, so pause if you don't want to see them yet. You should end up with 3, -3, and 1 respectively as your x values. Now guys, if you have any questions, you know you can email me. Don't forget to upload your